Example 2 asks us to expand each of the following. So we have a plus b over 2 to the 5th as our first option. So again, if it's to the 5th power, that means that we are going down in our Pascal's triangle row, because you got to think about all the different combinations of kind of the crossovers of these multiplications. So if we make our Pascal's triangle, remember it starts with row 0, so we're 1, 2, 3, this is 4, this is 5. So this represents the descending powers, like the count of the descending powers of our first number. So we have 1, 5, 10, 10, 5, 1. So the way this is going to start looking is all of the powers go to the first part. So we're going to get 1 times a to the 5th times b over 2 to the 0. And then we keep trading off. So this, and then it's going to be 5 a to the 4th b over 2 to the 1st plus 10 a cubed b over 2 squared plus 10 a squared b over 2 cubed plus 5 a to the 1st b over 2 to the 4th, and then finally plus 1 a to the 0 b over 2 to the 5th. So we just have to break that down and simplify that as much as we can. This is going to be the first part. It's going to simplify to a to the 5th. The second part, we get b over 2, so we get plus, it's going to be plus 5 halves a to the 4th b. So we can split that up. Remember, when everything's multiplied, it makes it very easy to rewrite things. And we have plus, so we have 10a cubed b over 2 squared. So that's b over 2 squared makes b squared over 4. 10 over 4 is going to be 5 halves a cubed b squared. We then have 10a squared b over 2 cubed. So over 2 cubed, so 1/2 cubed is 1/8. 5/8 is the same thing, or excuse me, 10/8 is the same thing as 5/4. So we get 5/4 a squared b cubed. And we have, 5 over 2 to the 4th makes 16. 5/16 can't really be simplified. So we have a b to the 4th. And then finally we're going to have plus 1/32 b to the 5th. Because 1/2 to the 5th power is going to be 1 over 32. So this is a big expansion, and instead of having to multiply this out 5 times or 4 times, we were able to kind of use what we knew about things to kind of set it up easily. So it's a very useful tool, especially when you get to more complicated problems. So the second one was 3x minus 1 over x to the 6th. So we had 3x minus 1 over x to the 6th power. So this one, because we have these different variables of x, it's going to make things a little strange for us, but we just do it the same way. This time we use 1, 6, 15, 20, excuse me, 15, 6, 1. All right, we use our next row. And so we start out, 3x gets all of the power to start, right? So we get 1 times 3x to the 6th power, and then we have our negative 1 over x to the 0, plus, so we go 6, 15, 20. So we got 6 times 3x to the 5th times negative 1 over x to the 1st, plus, 15 times 3x to the fourth times negative 1 over x to the squared plus 20 3x to the 3x cubed times negative 1 over x cubed. And then let's see, so we got 15, 6, 1 plus 15 times 3x squared times negative 1 over x to the fourth plus 6 times 3x to the first times negative 1 over x to the fifth, and then plus 1, 3x to 0, negative 1 over x to the sixth. Very, very long expansion. It would have been a gigantic pain to do through multiplication, but through analyzing it, it makes it a little easier for us. So we start off at the beginning. So 3 to the 6th power, that's, let's see, so 3 to the 4th is 81. So it's going to be 729. 729x to the 6th. Plus. Or, well, we might actually be minus. Hold on. So we have 6 times 3 to the 5th. So 6 times 3 to the 5th is, well, 3 to the 5th is going to be 243 times 6. Let's see. 243 times 6. It's 1200, 14, 40, 1458. Is that right? So it'd be 8152. I think so. So this is actually going to be minus 1458 because of this negative sign here. Now, instead of it being x to the 5th, because it's over x now, it's going to be x to the 4th power. So we're going to descend by powers of x squared. So then we got 3 to the 4th that's 81 times 15. So that's 810 plus 405. So that's 1215. So we get 1215. And this is going to be x squared. And then because of the way that the minus is moving around, that was from this, it's because of the way the minus is moving around, we are going to subtract now. Goes over here. So 27 times 20 makes 540. So we're doing minus 540. All right, and the x's cancel because we have x cubed and x to the negative 3. So it's perfect, so it goes away. Oops. And then we keep moving. So here we've got 15 times 9, that's 135. So this would be plus 135. I'm going to call it x to the negative 2 because that's what's going on here. We can see that it's dropping by 2 each time. 6 times 3 is, so we got, this is going to be minus 18 x to the negative 4. And finally, we're going to have, this is just going to be plus x to the negative 6. So this one is different in the sense that since the two terms were kind of similar, that we could end up with excuse me, so we could, because these two terms were similar, we could end up with terms that kind of overlap, and they end up with these descending powers by 2 instead of by 1. So this is a good example. Just make sure that you're looking at your Pascal triangle and you're paying attention to all the little details as you go along.